Sometimes works. Perfect. Seems like it's working. Awesome. I guess I have everything set up. Thanks for waiting a couple of minutes, more than that. Before we start office hours, I mentioned, perfect. Word is better with the classes. Office hours, let me know when works. I can think of other times, maybe. What about Mondays? Do you have any courses or classes on Mondays evenings? You have on Monday evenings. And I guess you don't want to attend the office hour earlier in the morning, right? 8 to 9? Before I go to work? Or what we can do, it's tricky if I do it midday, so some things might come up. I might be pulled into a meeting or something, so I might miss it. But if nothing works, what we can do is that we can do it between noon to 1 on my lunch time on Tuesday. What about that? Would it work? Yeah? So maybe lunchtime then, on Tuesdays. So we both both sides have to sacrifice something on the lunchtime. Anyway, it's a limitation on my side, and I'm sorry about that. But we'll see. If that doesn't work, we'll see about what we can do. That's one thing. The other thing is that in the announcement of the first class, I mentioned that if I will talk about that one actually. So let's go with that one. All right, second session, I wanted to talk about resumes, so I will talk about that one. Second session, first session we talked about a couple of items. Oh, wow. So let's see. Let's get into the second session. We will review. Not gonna repeat the mistakes from the first session. Let's see what I have for the second session. I have a couple of questions, including a review of things that we learned through the first session. If you want, you can scan that QR code so you can answer the questions. If you don't want to scan that one, you can go to this website, enter this number. But I encourage all of you to do that. Let's see how it goes the first time I'm trying it. All right, you all have it? You all got in? Take your time. And you probably see the same view as I'm viewing, maybe. Wait for me to start it. Is anyone not in that link yet? All good? Perfect. So let's get started with that. You saw the question. How would you rate the class so far? Mainly based on first session, I guess. The thing is that I don't want to wait for the end of the quarter to ask you that question. So as we are going, I keep asking you. Let me know if things are not going the way they should be, because I really care about your experience. That's interesting. I guess you should have entered that, right? Don't overthink it. You're so kind. Less kind now. But yeah, thanks for the feedback. So the main reason that I'm asking it is that if you are here, or possibly here, but you think you might be here, just let me know what goes wrong, okay? In some ways. So what we can do, I appreciate that. 22 people sounds right, but you might still have time for it. Perfect. So I stop at that. Seems like we're not at 1 or 2. Maybe by the midterm I can achieve that part of it or unlock those parts. Let's go to the second one then. I can keep this one on. What are the things that can make the class better? I assume you can answer that one. Let me know if you can't. whatever you write will be showed here. So kind of you. Sure. Let's decipher that one. Post notice scale makes sense for week 10. There's one way of reading that one. Learning expertise, reading more, building with Python. We'll talk about that part. Post lecture slides before the class. Sure I can do that. Python rather than R. Post homework ahead of time. That's also a good idea. A project would be a fun thing. All right, so thank you for the positive feedback. For doing things in R versus Python, I had a chat with Professor McLean as he's basically leading these two courses, two sessions. I'm kind of basically taking it over from him. And he has a better sense of like the bigger picture. So I basically passed the message that you guys are also interested in learning in Python. And you might think that R doesn't have a future for it, though. He mentioned that through the 2-year plan that they have for you through different classes, you have the option of choosing between Python and R, so you will be definitely exposed. There are courses that only cover Python. So again, you will be exposed to Python. They want you to have exposure to R as well as part of this class, and maybe the one after that. So that's the main idea. That's what I can cover, and I mean, pass through the message that I got from him. But from my point of view is that if you learn to do something, what we are going through this course is basically building a mentality. So you build some skills, you add some tool sets to your skills. So regardless of which language you're working on, you're going to be able to do that. Would have been more fun if you do it all in Python and if you like Python, but R is also an interesting language. So time to time you might be using it, and remember it was a good thing that you learned. That's about R and Python. I care about your suggestions, the things that you want to do and the way that you want to do it, but that's as much as we can do. So let's focus on R for this course and probably for the next one, and keep the passion for Python for the other courses. Hopefully soon you'll get a couple of courses that will work on that one. But if you rather the IDEs or the environments that you've been writing code with Python, we can cover it. I can cover it partly. You can easily have it on a Conda with R kernels or Python kernels, so you can write codes in Jupyter Notebook and get rid of the kind of older view of the RStudio. But I guess that's about it. That's as much as mitigation that I have for myself. Not for myself, but to share it with you. Slides are a bit too dense on the text. I have a purpose for it. Let me know if I'm wrong about it. I'm thinking about on the midterm, when you want to go through the slides and remember what I was talking about, I just want to make sure that you don't have to go to the lecture text or the book. So you have enough text to remember what was going on in the text, or when you see a plot, you have all the items that I talked through, so you have the talking points. That's the main reason. Also, the slides are made mainly between 10 p.m. to midnight or after midnight by me, after work and after putting my baby to sleep and doing all the chores at home. So these are the rough first draft of it. The course doesn't have slides. So I think the slides help a lot for me and you to go through the course materials instead of me reading through the lecture notes that I post every week. That's how I'd like things to be. But it takes time or revision. So if you have any suggestion on improving them, let me know. I try to make them to have less text, but that was the main idea. Anyway, practical experience, I try to define a project. I have to think about it. I try to have a kind of like a term, like a bigger project. Hopefully if you, something like 1 or 2 or 26 people, maybe 4 or 5 different groups. So you have teams to work on. So you have the experience of team working using Git and things like that together. So that can be helpful later for your resume as well. You put something in your resume that you have, though your resumes are pretty good from the things that I've seen so far. So sure, that I will do more coding examples. I definitely will go through this for the first session with, again, enough time. Today we will write more codes, so you get a sense of how to do the things in R. You have to have exposure, and I have to write code for you. I will do that. What did I say? What did I see? I can post the slides earlier as well. If you like to have them, I can do that. They are ready mostly before I leave home on Wednesday, so I can do it on Tuesday nights. The main reason that I don't do it is that it's kind of it might help to be more engaged when you see things for the first time. If you go through them, you know that already we're going to talk about linear regression again this week. You might not be as excited as you can be.
Well, at least for some of us, it's so that we can have the slides and like write our notes on the slides when we're.
That's a very good point. So I definitely would do that. So there's a trade-off. I'd rather that part to be done. Sounds good. So I will make that one. So I make the slides available. Homeworks, though, I think if you have it after the class might be better. May I know the reason you want to have the homeworks earlier? And the reason I say maybe it's better not to have them earlier is that it might keep your mind thinking about them through the class. I might be wrong, but how would it help to have the homeworks earlier? Let's say and the other reason is that you're not yet done with the last week's homeworks at some point. So maybe as soon as I post the solutions for the homeworks, which will be end of the day today by midnight, I will post the next week's as well. That's as early as I was thinking about. But if you can think of a good way or better reasons for it to be, since basically I can just kind of publish all the homeworks for the term so you know ahead of time. But anyway, so that's the other thing. Something broke up is like tokenized here. Can someone guess?
It's because the way that the responses were worded, each line was like, write a word.
Oh,
Okay,
I see. Bad UI on their side. Makes sense.
Yeah.
So probably post the homework sooner. That's one of them, right? And the other is post the reading. And I think this one was 10 on the scale of 110, rating of the class. I'm hoping that's the case, or the other way. Anyway, so I will make sense of those ones. That's a deciphering practice for me. And then, don't want to spend too much of time on this one, since I already don't know how much time we will have for the rest of it. And let me know what are the topics you remember from the first week. Kind of a review for you as well. Just topics, 2 words, 3 words, 1 word. Perfect. Love it. Awesome. Have you ever played the drawful game? No? It's kind of a nice thing. Someone draws something and others try to guess what the word was. It just reminds me of that one, so the items there. That's a fun game. Anyway, this would be a great slide for the end of first session. Probably next year, whoever teaches that class, if it's me or other person, it would be a great thing. So I'm really glad that you learned all of these ones, and I don't see the fact that you remember the class was boring from the first session. I'm super glad about that one. Today, we will dig a little bit more on linear regression. I'm super happy that you learned all of those ones, at least you remember those. And I have one more question for you before getting into the second question. Do you want me to go through the questions and answers, or you got it all right? So, perfect. You have, I guess, like 20 seconds or something for these ones. Perfect. We all mostly get it right. So this one was the decoy option. Supervised learning methods mainly work with the labels. So in order to be supervised, we have to know what the real answer is to be able to supervise it. I know it kind of makes sense for unsupervised one to also kind of supervise it, but that's the main idea behind that. Next one. So I know you weren't able to see the questions before I start them, right? Okay. First time using this tool, I kind of like it. And next time I will increase the time of it. I wasn't sure. I thought that you will have time to see all of them. All right, good. Well done. I think you should be the last one. Awesome. It makes sense to be a split between the ones, especially that we didn't write it ourselves, so we went through some of the block of the codes, but basically all of them are true. So we roughly went through one of them. The last block of the code that I was pasting all together, we don't, nicely done everyone. I really don't want to compare people. Anyway, I think that tool should have had an option for it. All of you want the game for the quizzes. Always. So let me see if this one tracks me. Get to the actual, not this one, we're done with this one. So Seattle University, we talked about having summer internship or full-time positions. I sent an announcement. If you're interested in any of those ones, what I need from you is, what do I need from you? Perfect, resume. So it works great with the university name. That's the maximum, that's my creativity at best. So that's the best you can get from my creativity. So, all right. I hope that way you can at least remember. Feel free to share your resume, a little bit on that one. So I have very limited resources to help you through the process. Things that I can help you with is reviewing your resume, which there are a lot of entities in university and great people out there that can help you as well. I can at least have my 2 cents of things on your resume. Second thing is that if you see a position on Amazon for summer internship, please do it faster as you can do for next summer. It's already might be late maybe, but maybe not. For full-time positions, the same. What I can do for you is that I can refer you. With the referral might be helpful for some of the steps. You might not get like the phone interviews and such. You might have a higher chance. I'm not really sure or clear on that, but hiring people care about internal referrals. Also on my side, for clarity, I will get a bonus if you get the position. So it's a win-win situation. Having said that, if you find anyone to refer you in another company, know that they should be super happy to refer you. Don't think that it's a burden for them. It's super easy uploading your resume, going through your resume, talking to you about the roles and doing it. It's definitely worth it for them and you, and for them, especially for getting the bonus and such. So reach out to people on LinkedIn, on companies that you don't know anyone, any friends or such. Ask them for doing the referral. They should be nice enough to do that. Things that I wanted to mention are this one. On other companies, I definitely have friends. You definitely have friends, but feel free to reach out. And the other thing is that apply as many rules as you can do. It's a game of numbers for most part of it. So a lot of things should come, at the right place. You should be the right person, right time, right situation, and such in order to land on a job. It's not necessarily 100% depends on your skills. So it's better to have a large number of them. And hopefully I learn how to go forward with this too. All right, that's about the resume. Missing part that I forgot to talk about during the first session. Let's get into the actual course of it. And whenever I do this one is mainly to get attention of the camera so you can track me. So linear regression, what we talked at the first session was an overview of what linear regression is about. Linear regression, ideally, if we know what is happening by the data, we want to find the true model that can describe the relationship between the tools, between the data points, right? But going to the real world problems, we don't know the actual model, so what we can do is to approximate it. So approximation is the best thing we can do as real as we can do basically with regression and other things. So instead of having the most optimistic way that we described it earlier as y equals mx plus b, we don't know that y actually equals that. So we say that y is approximately modeled by a linear function. And linear function, because we have beta 0 plus, that's the same as mx plus b that we went through in the first one. It's more generalized, or I can say like a fancier way of doing it. It's more accurate. Let's put it that way. So that's a notation that will be used in the course, that will be used in your homework, so it's better to get a sense of it. Y equals mc plus b that we went through the first session. Same as this one. Now we have the parameters and we have the coefficient, and we don't know if y exactly like that, so we say that it's approximating that. Then we have the notion of error or residuals. So residuals for any data points that we have is the difference between the actual ones versus the one that we calculated. We went through that one, but we didn't talk about RSS. What RSS is, can you guess what the name is? What is abbreviation of which word? A couple of words. Residual sum of squares. Perfect. Residual sum of squares is basically for each data points, we calculate the residual, square that, get the sum, we get the RSS. Then we have the standard variation of the error, which is the RSE, residual standard error, I believe that's the name, which we calculated based on RSS. Next step is to get the total sum of squares. The total sum of squares, it actually, as it suggests, is the sum of the differences that we get, sum of the squares. It would be the total error that we get. Then we have the R square, and the reason we go through all these steps and hops is to get to here, to R square, which is defined by 1 minus RSS over TSS. What R square shows is give us a good estimate on what portion of variance in the data set our model covers. So it's basically a notion of quality for our model. So the more we cover from our data points, the less error that we have. It helps us to get a sense of what kind of, is it a good model or is it a bad model? And why do we need to do that? Because going back all the way there, we don't know what the actual model is. We are guessing it, we are finding the approximation. So we have to be able to compare models one with another one and decide which one works better. And that's one of the measures that we can use. All right? Makes sense? So we have a notion of error. We have a good equation that we can know what kind of errors we are covering, and then we're using R square for that. And that's an important thing. We'll see it, we'll work with it, and we know how to deal with it. Then we will see it more in R in the model results, and you will remember it better that way. Then we will talk about like a single regression, single linear model. Here, if you want to expand on that in the real world, it's not just one parameter that we work with, it's multiple parameters. So it's called inference for multiple regression. The way that we do it is that this time we're not saying y equals, but it's y hat, so it's the value, the perception of value that we have, the predicted value is equal to beta 0, beta hat 0 plus the rest of it. Basically, we have different predictors here. So now we have multiple features, multiple variables to work with. All right, and this is called multiple regression. The main questions that we have to answer when we have multiple predictors are these two. We have to focus on this. I don't need to touch the screen. I can do this. We have to focus on these two, right? So we have to say, does the model provide value in predicting Y? And we will get into the bottom of what it means. And the second one is which predictor variable are useful for predicting. Two things. Do we have a good model? And are we using the right features for having that model? All right, so these are the two questions. Now, just to make sure that I'm not going super fast or on the wrong direction, I'm asking you this question. How is it for a simple linear regression? We talked about multiple predictors. We have to focus on those two questions. If we have only one predictor, so it's a simple regression, what would be the answer to those questions? How those questions are different then? There's only one variable. So we don't have to answer whether it's a good predictor or not. The only thing we should answer is that whether we have a good model or not. So basically, to put it on the other way, the two questions are equivalent for having only one parameter. We don't have to answer both of them. Kind of common sense. All right. So I kind of rushed it through to get to this slide because I know, based on your feedbacks, you want to see me writing more R codes, right? So I will do that. Hopefully soon. But I will do that. So let's get to this one for this model, and we will generate it ourselves. So we have hands-on. When you have a model, we had the linear model, the LM1. It's a linear model. We provide the formula. We have the Y. We have the predictor passing to that model, right? And then we want to get the sense of, at the first session, we weren't getting a sense of how the quality of the model is because we were generating the Y values and we know what the model was. We were just playing around it. Now we want to go through every single thing that we can get from the summary of that model. And you will do it in the real world when you're working on a problem. You're generating results for a model. You want to get a sense of how good or bad it is. The first part of it, the main way to do it is to write the LM. I will do it first. Let me go through this one. Maybe it's easier to read it here. For the linear model, we get a couple of items when we get the summary. Residuals are the main ones. And the values you get here are basically the values you need to create what kind of plot? Can you guess? Box plot. Perfect. So a box plot, you need the minimum, maximum, Q1, Q3, and median. So it shows you where the residuals are landing. If they are kind of normally distributed, then we know we are having a good model overall. So that's one of the sense of. Overall, we want them to be as close as 0 as possible. So that's the purpose of showing what the residuals look like. And those are epsilon i's, or these are the individual residuals that we have. Then we have the coefficients. So the formula that we have are x1, x2, and x3. If you go back to that, maybe too much back here, so these are the coefficients. The intercept would be this one, x1, x2, x3. Then we have it there. All right, so these are the ones. So intercept, the estimated value are the actual values. So when you look at this formula, it will be y hat equals 152 something plus minus 2.42 x1, 4.83 x2 plus 0.0 x3. So this is what it shows. The second one shows the standard error around the estimated value. So we weren't sure about 152. It's not something we were super sure about it for this model. We had some level of error around it. So kind of the model played around those variables, but it's like 30 points more or less probably works around the same thing. And we have the t value, which shows basically the estimated error over the estimated values over a standard error, all right, which gives us a sense of how confident we are about the parameters. And finally, these are the p-values. Do you all know about the p-values and hypothesis testing? Yeah? Perfect. So I can assume you know, but still I have a slide for it. So I will cover it shortly, then like maybe briefly, but these are the p-values. And for p-values, remind me, should it be high or low? Low. And when it's low, what does it show? Can someone explain it to me?
Probability of a false falsely detecting the effect is low enough that we can say that there is an effect. So in this case, we would be saying that the probability that the parameter isn't actually a useful parameter is low enough that we can include it.
Perfect. You touched on the main aspects of it. Exactly. So the lower p-value we have here, it shows that it shows the importance of the feature. Basically, the two hypotheses that it's testing is with the intercept or without the intercept. And the second one is with the intercept and this one or without this one. So we have the H0, the null hypothesis, and the null hypothesis of not using the variable, hypothesis of using the variable, and then we compare the differences and actually creating the t-value, and then we have the p-value for this one. Lower the p-value is, these are the thresholds. Lower the p-value is, if it's 0, then we have the most significant ranking for the feature. So the stars here is also kind of coded here. So by the look of it, without even looking at the p-value, you see at the stars, you know that these two variables are really important. This x1, relatively important, but this one has a bigger p-value, slightly more than 0.5. So it's kind of, it's not even getting that one, right? Yeah, 0.52. So it's not a significant variable. So that's how we know the first question. Do you remember we had to answer two questions? Which predictors are good ones, are contributing to the y variable, and overall how good a model is? We are trying to answer those two questions if you're not sure what I'm going through. This one answers one of the questions. Which predictor is important, and if they are contributing towards the good model? Now we know these three are, but not this one. And then how good of a model we have? Can you tell me how we can identify that one or answer that question?
R squared value, I believe it means that 68% of the data is captured by this model.
Very well said, exactly. The R squared, it shows that 68% of variance in the data points are captured by the model. It's pretty good value. So we have good on that one, and then we have the F statistics that confirms the value. The higher the F statistics are showing that we have a good model. Adjusted R squared is a little bit penalized based on the number of parameters that we have. So the more predictors we have, it will be lower. It will be lower based on the number of parameters. It kind of, if you think about it, if we can get a good model with less number of predictors, that's the ideal situation. And the 96 degree of freedom, I can expand on that one, is basically number of data points that we have here. We generated that data with 100 different data points, random data points. We have 4 predictor or coefficient there, minus that one. It's basically we have 3 predictors, x1, x2, and x3, and the degree of freedom is usually number of data points minus parameters minus 1. So it's going to be degree of freedom is 96. So we want it to be high because we have to have a good balance, like having 100 data points, having 100 predictors is not a good situation. So we can lose our kind of credibility of the model that we have. So overall, these are the items. When you get a model summary, you train a model, you get the model out, this is the summary, and you have to be able to discuss all those things about your model so we can compare them. So let's do here. Let's see where we are. I think I have some of them here too. Or maybe not. Let's see if I have some of those. Yeah, that's way better. All right, so let's start from these parts. I want you to also see all those ones. All right, so let's start with these ones. Just rather not to write them. I go through them. I can write them, but it just takes more time. So in order to create all those results from the model, right, we can start with the set.seed 1, 2, 3. And you know why we set the seed, right? Can someone tell me why? exactly, to generate the same sequence of random numbers. So if I set the seed to that one and then do our norm 5 or 5, I get these values. If I set it again and do again, I get the same sequence of numbers. But if I generate another 5 numbers, I get another ones. Because this means the first ones is the first 5 ones, and then I get the second 5, so they should be different. But if I set the seed again, and then generate this one, and then generate it again, I get the same exact sequences. So doing that way, x1, when I create them random, generate them randomly, x2, generate them randomly, and x3, every time with seed 1 to 3, we'll get the same results. So that helps me and you to have the same exact results as we see here. Then we generate 3 predictors with 100 randomly generated values for x1, x2, and x3. We're trying to generate some synthetic data and then try to generate a model based on that. The next step is creating the y values because we don't have them. And in order to make sure that the model is going to have residuals on that, we have some randomness in the data, the way that we are generating them is that I have some intercept value predefined, and then I have a coefficient for x1, coefficient for x2, coefficient for x3. Oh, x3 is not here purposely. Instead of x3, I'm adding a random number. Sequence of random numbers there with the standard deviations around things. So that way, my y value is going to have some deviations around, some randomness in them, and then the next step is generating a model. So if I generate a model, and I have a syntax error there, of course. So you see my history, I also did it twice. So model is assigned, the variable model is assigned to linear model detection. If I haven't mentioned it, I expect you to also do it in R as we are doing it together. So I make sure that we all gonna are able to go through the code. So we don't have any problems with that. And then I have the model based on this formula. I said that we have like 3 predictors. It's a multiple regression, and I have the model. Then I guess I can do a summary of the model. When I do the summary of the model, you see the results is exactly as what I get in my slides. Not exactly though, because of the randomness. But the values are around the same thing. Do you remember the coefficient there was 152 point something? Now my model is thinking it's going to be 149. But overall, the same situation we have here. Now, with all the things that I mentioned, can someone walk me through why x3, the p-value for x3 is kind of larger than the threshold that we expected?
Because you didn't use it when you were setting the value stream line.
Exactly. So we expected x3 not to be a good predictor for y values because we never use it, right? And the model now confirms that part as well. So I know that things that I mentioned to you are correct. So that's the way. We want to know how our model is working, what it means, and things that we have here. But our R-square is not that good as it was before. So it's like 39% of the variability in the data. All right. Any questions so far about interpreting the model's characteristics? Hopefully that makes sense. So anywhere that you see the outcome for the model, or anyone came to you and said, oh, I have this data set and I have this linear model trained on, you know how to assess the model they have. You know how to talk to them about the quality of the model. Or if you are doing it for someone else, they are willing to see these things. So when you see I have a good linear model working like a charm, then you have to look at these ones as well. Next thing is that you probably see me doing around, just let me make sure that I don't have, oh, I also have this one because I like box plots as well. It's too early to do that though. So pressing escape, gonna remove what I was doing. So I have to do residuals, yeah, something like that, of residuals of model. There we go. I think that way works. All right. And then I can do the one that I was doing before. So maybe not this ones, but this ones. There we go. And that's the box plot that I was talking about. So I get the residuals of the model, assign it to a variable, use that variable in order to create a box plot. And that box plot shows, I think one way I can add also the reference value. At least I was trying to do it last night with something like this one. Perfect. So then I have with the AB line, I have the reference number on the 0 residuals. We expect them to be around 0. So we have a sense of like where our residuals are sitting in there. Visually, we saw the numbers up here somewhere. They showed me the minimum, the maximum, the different quantities that we have. But here we have the minimum, maximum, mean, max, Q1, Q3, median values. All right? A little bit of there we go. So, all right, I think that's as much as we have. We want to talk for now on this R part, but we're going to continue doing it. So for the model, we talked about the variables, the p-value, and the way that we know which variable is contributing towards having a better model. Now we want to talk about variable selection. Among these variables, in order to have a clean and tidy model, we want to see which variables we want to pick. There are different methods for doing that. Intuitively, when you see the value like this one, intuitively, when you see a value like this one, you expect that you don't want to use x3 anymore, and you have a right guess. So the next iteration of the model that you want to work on is basically using, let me see if I have it here. Variable selection, using it a backward selection. So we add all the variables that we have and we start eliminating, or they call it backward elimination too. So backward elimination is basically add all the predictors that you have on your data sets and keep eliminating the ones that are not contributing. And they are not contributing if the p-value is larger. So next iteration of the model is going to be x1 plus x2. And now we look at how the variable or predictors are doing, all right? And we do it until we get a sense of like remaining at the way that the model is only with the ones that have an acceptable level of p-values for the variables. Or we see that we're not improving here, but we are decreasing on the R-square metric. So either of these two, we stop at that one. So that's called backward elimination. The other way for doing it, and the other thing is that, another example of that, so you have to know about different situations that you do the backward elimination. Imagine this example, this is a different one, that we have these two variables, the p-value is high, so both of them are not contributing to the model, right, as expected. What would you do? Would you eliminate both of them at the same time or one by one? Both of them? To have faster iterations, to get the results faster? You can show your hands if you agree with that part. No? All right, so we do it one by one. And the reason for that is that we eliminate the one with the highest p-value at the first iteration. Let's say x1. And then we are remaining with the x2 and x3. The next iteration shows that all of a sudden x3 is contributing hugely to the model. Can you explain why that can happen? The reason that it can happen is that maybe both of them together, they're not contributing as much as we expected it. The other reason that it can happen is that both of those variables are correlating with each other a lot. So they're not giving much of the information, but if we remove one of them, now we rely on only one of them instead of both of them. Instead of slightly relying on both of them, we are hugely relying on one of them. But the information that they are providing for the model is the same thing. So that way, you see, only using one of them is enough for the model, and then we can confirm that. And the way that we can confirm that is to have the correlation, the pairwise view of the both variables. So when you look at those variables, x1 and x3, probably they have higher correlation. High correlation means that they are on the line x equals y. So you can get that plot with the pairs comment on R as well. All right, so backward elimination, one by one round in each iteration or each round that you have, and then check for the ones that are doing better or worse. There's another way. When we have backward, we have forward, two for the forward feature selection or forward variable selection. As you can imagine, that's the intuitive way, adding predictor one by one. So y equals x1, and then you add x2, x3, keep adding it forward. And then we have the hybrid approach. So in many approaches, when you have one way, then you have the second one, then you have also a hybrid version as well. In auto industry, you have the same thing, right? So you have gas powered, you have electrics, and then you have hybrid ones because they work well. So I want you to remember, so always mixed ones, not always are better, but they work better for different situations. Backward selection is really good, it's really simple. It also helps you to get as close as possible kind of to the optimal results, but it works only if number of parameters are less than number of the size of data points that we have. I guess you also faced P and N in your homeworks as well, and you didn't know about it. All right. It's partly my bad, but also the intuition for it was that you can also take a look at the course material, like the book itself. Kind of scroll a little bit down, up. The book has more content that I cover in the class, and it's expected from you to know for the midterm and such, but it's nice to, kind of skim through all the aspects that it touches as well. That wasn't by intention. I would have introduced PNN in the first session if I had went in depth through your homework and guessing that you might have the problem with that, but at least look at it from the positive side of things, that you could have been exposed to the what the book is suggesting, the material that it has. Second one, forward selection, we have color coding here. So backward selection, simple finds, simple in helping us to find the good results. Forward selection is more complex and it takes more time. You have to add all of them. Probably in the backward selection, you finalize the results faster because you can eliminate some of them and you leave, you're left with the fraction of those that you want to use. But forward selection, you have to do it one by one. It can be used when the P is more than N, but the problem with that is that we might end up with redundant variables. The situation, the variables correlate, we're slightly getting improvements, we keep them, we don't know exactly what to do. Then, in order to fix that one, we get to the mixed selection. The mixed selection is also called stepwise selection, if I'm not mistaken. So if you hear like stepwise feature selection or variable selection, that's the same thing. Don't think that I haven't covered it in the class. And then I guess that you might not remember how the statistical testing process works. Maybe you know it now, not by the midterm or so. So I put this the slides, you can go through that one. The main important part about that one is this part of it, and hopefully I covered it right, is that know that the p-value doesn't tell us necessarily about the probability of something happening. It's basically about one good definition that I find is that it's a probability of observing the data under null hypothesis, not necessarily observing the data. So it's the difference. In some of the interviews, try to kind of internalize what the p-value is and hypothesis testing. If you want to get into data science positions, if you want to get into machine learning engineer positions, some of the interviewers love to ask questions about p-value because it's the basic understanding or knowledge about the statistical process, and they would love to test you on that one. Some people just love to have, easily get a sense of where you are in the interview process. I don't like it personally though. So knowing what p-value does is really important. I put it into that slide. Since you mentioned you know about it, I'm not going to go through that. Now I have a request for you. Go through the Canvas page, find the module for the second week, find the lecture notes. In the lecture notes, you will see the practice activity. And I want you to go through there because I need you to download that data set, put it in a directory where you are writing code, and then go through the questions here. We can go through the answers together, but I want you to do it on your own, downloading the data set, putting it into a directory, and try to see what part of questions you're able to answer by your own before we review the answers. Just to make sure that we are making progress, were you able to find the practice activity on the Canvas page? Perfect. So I guess by now you should be able to download the file. And what I did, I basically put it somewhere in my codes, in my class, in session 2. So I put it under the directory that I want to work with. And then in console, I was trying to find the right command for doing it. I think I used set WD, set working directory, in order to set the directory. So if you're here, set WD, and then pass the directory string. So the codes that you're writing then would be looking at the directory that you're looking at, or you have the data set in. I think it would also autocomplete as well. So if you use that one, what is it like? Yeah, it would autocomplete, just slash would work. On Windows, you can do users and then the rest of it. I think it's the read one we wanted to do and the rest of them, right? Perfect. Were you able to load the data set already? Yeah? Perfect. So let's see what the activity asks us to do. If you don't have tidyverse or read Excel, you can install it, install.packages, and pass the tidyverse as a string to that. Same about the other library. Tidyverse, you can also check out their website, kind of put together here a good kind of a combination of aggregation of packages you might need overall. So what it asks, suppose we wanted to create a model to predict digestion efficiency, start by feeding the model using both weight change and fiber to predict digestion efficiency. So digestion efficiency is going to be our y, and then we have two predictors, the weight change and fiber. If anyone was able to have the first model, let me know. Perfect. Good. And the main reason that I'm asking is not a competition. I just want to make sure I'm not waiting for you and you're not waiting for me. Alright, so I guess the first part of the question, what it's asking for is basically predicting the digestion dot efficiency. That's a name that we chose for the y, for the labels, right? And we want to predict that one based on weight dot change plus fiber. So those are the two predictors. So if we run this code, and again, we assign it to a model, you see here at the bottom two, or if it's easier on top part there for my history, you should give us the model, and you should give us the information about the model. Perfect. And I have typo in my history. So that should be the outcome. Hopefully you were able to generate the first part of it, this part of it. If you were not, if you're struggling with an issue, let me know. If it was only about choosing the right parameters, choosing the right predictor names and such, it's fine. You can play around it. But if you have technical issues with R libraries and such, let me know. So it's the same thing that we talked before. Y equals x plus y equals x1 plus x2. Now it became the real world problem. So it's digestion efficiency described as weight change plus fiber, and we want to see if we are doing it what we see is that weight change is not really contributing towards that model, does it? Probably not. Big enough p-value, we also don't see the stars next to that, so it's not shiny enough, but our model is doing well. 77% of the variance is captured, and we have a relatively high F statistics as well, so we should feel good about it, except we have to do one thing. What is it? What should we do here? Eliminating this predictor and probably choosing among the rest of predictors that we have. All right, so that's the main purpose. That's the same exercise that we had. And the second part, if a variable not significant, consider a simple one, the new model digestion. So for that one to be done, what we want to do is doing this one, and then go here, and then weight change wasn't a good one, so I want to do this one and get the summary of that. Without that one, all the features that we have are significant now. We haven't, as far as I remember, we haven't lost on our R-squared. It was around the 70.77 or 77% as well. And the FS statistics, it was around 70 though, right? So it's kind of doubled, even better for us. So we have a good sense of things that are happening. We could have remembered the residuals, but we don't need to do that because we know that R-squared, the very first slide that I went through, goes all the way back to all the residuals that we have. So we are covered. We don't need to look at this part necessarily. And these are the things that we wanted to do. So that's about having kind of hands-on experience with the real world data, and then playing around. So any data sets that you might have access to and you want to give it a try, that's the best way to do it. You can even have notion of, so backpart selection, if you think about it, you better have a script around it, right? So you don't have to do it manually. So you can get access to the values, the p-values from the variables. You predict it with all the features that you have, get the lowest p-value, eliminate that one, generate another model, get the p-values, eliminate the bottom one, the worst one, keep doing it in a script. It's like a pipeline, data pipeline for the steps you're gonna do. And then also capture all the variables like R-squared, so you know that you're not only like improving on variables and losing on the R-squared, and you are doing a better model there. All right? Before we move to the very other end of the slides, any question for me? And does it make sense why we are going through linear regression again in this session? So we are getting more into details of linear regression. The first session, we just reviewed a lot of different models that we knew about, the different topics, supervised, unsupervised, KNN, Bayes, and now we are going into this one. Next session, we're going to talk about classifiers and classification. So we're going to go deeper into each of those methods that we discussed at the first session. That's basically the purpose. So, all right. Talking about linear regression, we went from the simple regression that we had, and then we talked about the multiple regression ones. Now, what about the categorical variables? Not always the variables that we have, those are numericals, or like 1s or 2s or 3s. So we have categorical ones as well. So if you think about it, the type of food that, for example, some species have, for example, in the data set, they can be like, I don't know, like plant-based, like meat-based, different types of things. So we have categorical. We have to have a way to incorporate those variables as well. The way that we can do that is using the dummy variables. So one example that you will see in the course lecture is basically predicting the expected age based on the GDP of the different countries. And for that, we can have kind of dummy variables on different types of the location of the countries, which continent they are part of, or what's the country name. The way that we can do it, if we only focus on 2 continents, for example, like Americas and Europe, the way that we can do that is that considering that one of them is 1 and one of them is 0, not having 1 as the predictor is basically a model for one of them, and having the variable or predictor would be for the second one. And that's the way that we can incorporate the categorical ones. To put it in a way, it's basically the equation that we will have for the model with a categorical variable is basically like only having the average of life expectancy, which is the intercept, only relying on the intercept for the first continent, for the Americas, for example, and then adding an extra variable with extra coefficient for having the second variable in. All right, so this is the way that we can deal with the categorical one. If you have more than that, if you have like 5 continents, then it would be combination of all those. So we have like 4, yeah, it will be n-1, 4 different variables or predictors that will be added here. All right, the idea, I can actually click on that one. So when we train our model that way, it would be something like that. The difference going to be, so it's life expectancy is actually our y, and then we have the continent, and it gets the continent, it knows that it's categorical, it will create the dummy variable for us, which is the dummy variable of continent Europe. It just creates that one, and the way that we can interpret that is that for, I believe we know for this ones, if you look at the code, the way that it does is that only filter it based on the Americas and the Europes, right? And the way that it gets the answer is that the average life expectancy that the model would predict is 73 years, right? And that would be for the Americas. If the continent is Europe, it would add 4 more years. That's the way that our model is performing, basically, and dealing with the categorical data. We talked about the dummy variables. We talked about the averaging part that it does, the first part of it for one of the variables, and for the second one adds a variable, either it add to the average or reduct from the average. And it's a similar idea. Have you seen it before somewhere else? Can you remember where you've seen this method of dealing with the categorical values? It has a name. And it has 1 in it. One-hot encoding, exactly. So one-hot encoding is also the same principle, basically. Not necessarily super close to that, but it's the same idea around categorization. So it works for different, when you want to use like neural networks, you want to deal, like you're forced to use numerical values and you have high dimensionality variables, it's better to use one-hot code encoding. Then in your data set, you know, which it's kind of giving a signal to the model, whether it's whether it's red, whether it's blue, whether it's green, or different types. It helps a lot. Then, so far, about the regression, what we have been talking about, basically talking about the interaction, not the interaction, the way that we could have formulated predictors, it was basically x1 plus x2 plus x3, but some of the variables could have different impact on each other. One of them might be impacting the other one. So we kind of assumed that the variables were independent, right, in that way. Then we have the interaction effect. The interaction effect is where there's a relationship between the predictor variables, and the outcome of one of them is depending on the outcome of the other one. So if we don't capture that part of it, our model would be lacking something, or R-square would be low. So we want to make sure we are capturing that part as well. And the way that we can do it in regression is to use it in another way. Can you guess how? So it's y equals x1 plus x2. And now if we want to capture the interactions between them, we do maybe plus x1 times x2. So now we have the interaction between the two. So the variable going to be something like that. So the formula, the equation would be something like this. So we have the normal predictor impact on the model, and then we are capturing the interaction effect as well. Beta 3 is a coefficient that helps us to measure that interaction. And when you want to do it in R, you can do basically y equals x1 times x2. It would capture the sum of both and the interaction. Or if you have multiple interactions, you better specify it that way. So you have x1 plus x2 plus x3 plus x4, and then you have the interaction of x1 and x2, interaction of x1 and x3. And also, as far as I remember, in order to have the interactions, you should also include those predictors. So you cannot have like y equals x1 and x2 interaction, you have to have the sum of them first. It kind of makes sense, right? You have to have their impact and their interaction in between. Does it make sense why we have it though? Any question about it? So going back a little bit, on the things that we covered today, linear regression in more depth. We don't know the actual model. We want to have a good approximation of that one. And then we talked about multiple regression. We talked about what the model quality is, how to compare different models. We talked about R-squared. We talked about variable selection, how to get a lighter model but with a higher accuracy. And then we talked about what else? We had a hands-on practice, and then we had this one, the interaction between the two, right? I think that's around the time that it's good to have a break, like 5 minutes, 10 minutes, and then we're back for the rest of it. We're going to have another hands-on experience. So I see you back by 3:35. Yeah, all right, my bad. It was still working on the earlier data set, so it was about the digestive ones. I went one ahead. Anyway, so for that one, we can just do this one. My bad. So for that one, you can go through the one that we have without the interactions and one with it. So that's the model summary of model, no interaction. And then we get one with the coefficients. And find the one with the interactions. Yeah, this one. So we basically get the interaction between fiber and diet. We don't have to provide both of them. It will automatically cover fiber and diet as well. And then we can get the model, not this guy. And then we see the difference between them. Make sure I'm doing the right thing. I get the GP2. Yeah. So this is the plot that is talking about. Sorry for the initial mix up the two part. So it's kind of having the multiple regression lines for different categorical values that we have, the interactions that we have in between. It shows how it was trying to capture the two, basically. Right? Should be able to also compare the two. Yeah. And then when you have two models, you can also compare them with ANOVA. But I like the way that we used to do it. You're looking at the R-square better than this way, so we know exactly what we're doing. So get the summary of the models, then we can get a sense of how to compare the two models with interactions or without the interactions. So that's the model with interaction, without interaction. Basically, multiply them to have the interactions in between. And when you look at the summary of them, they're not really helping that much. But the model is good, 78. I think the earlier one we had was 77. It's lower FS statistics. One thing I wanted to also show you is that I talked about it, as I mentioned, if you like, about Jupyter Notebook. You can also have wherever you're writing your Python, you can use the Jupyter Notebook to do all the R stuff as well. Probably easiest way is to install Anaconda, and then from there install the IR kernel, the interactive R kernel. I think it's something called IR kernel. You install that environment as well as the Python one, then we create then a new notebook. It would create, you will have the option for both of them. So that way you can do both. But still for the homeworks, I'd rather you to start needing things on there, having the HTML. You can still do it in notebook, having all the results, and then just export it as PDF. I think it will give you both of them. Need them automatically. But for this one, you need the LaTeX one and such. So it might be easier on RStudio, but if we really rather to work on another ID, Jupyter Notebook is also the way to go, as close as you can get to the Python board. All right, so I wanted to talk about the model interaction and the way that we do it. I mixed it up with another one that we wanted to do next. But last slide of the day, last part of the course that I want to cover is basically we had some assumptions with the linear regression. First of all, it was about having the linear relationship between the data points, between the dependent and the predictors. But also we later expanded on having multiple predictors for the y values, for the dependent variable. And now we want to talk about a little bit on the non-linear situations. If the data is not linear, how can we deal with it? How can we still use the regression? It's not going to be linear regression. What is it going to be? Polynomial, exactly. So we're going to make the line definition that we have more flexible in order to be able to fit around the data that we have. So fitting a polynomial is going to help us a lot. So I thought that I put some values. We can use this one though. It's not the actual values versus the fitted regression line, but the polynomial going to be something like that. So instead of just straight lines that we have for predictions, we're going to have polynomials. So they are flexible to go around the data to predict it better for values that we have in between. So they're going to be something like this one. The other concept that we wanted to talk about today is notion of diagnostics, just to know how our model is working and how to go through them. Here we wanted to install that package, and I wanted you to go through the small data using the pipe, filter things, and then looking at different data. And I wanted you to use this function. Hopefully I can find it in my history. Basically the idea is that we have a couple of additional things to look at in addition to R-square, in addition to FS statistics for our model, to know that our model is working well, to know that our residuals make sense. And those are basically the residuals versus fitted plus we'll generate them. So it kind of give us a sense of where our residuals are, if our model is really covering things the way that we expect it to be, if it makes sense visually. And the second one is the QQ plot. The QQ residuals, they are expected to be on this line usually. If they are falling apart, then we want to know why our model was not able to cover the variance in our data sets, or the data that we have, they are outliers. So they're not good ones and we need to clean them. Here, when you generate the plots, you will see there are numbers assigned to them. You can think about it as IDs, and then on different plots that you generate related to that one, you can find them. So this is the residuals versus fitted, then you see the number 5, number 25, and number 50, and you can get a sense of those might be outliers for our observations. All right, you can remove them from your data set, you can clean your data set and then fit the model again. because these ones going to smooth out some of the values that you have. If you only look at the F score, if you F statistics, or if you only look at the R square measures without looking at where the data is, how the data is, whether it's cleaned, outlier or not, and where the residuals are, then you will miss on these parts. So one more thing, model accuracy, predictors, and then also looking at the residuals versus the fitted model and the other plots that we'll talk about, mainly these two ones, just to make sure that the data and the model are at a good place. All right? So that would be a whole pipeline of things that we want you to do when you are assessing a model and you are working on a problem to fit a model to work on. At the end of this process, we should be able to have a good predictor, a good linear regression, or non-linear regression, and you will be able to use categorical variables, non-categorical variables as well. So you have all these tools and skills under your belt. So that's mainly in terms of diagnostic stuff. The part before, I can end it and then take a look at the R part. For the next sessions, no more linear regression, I promise. At least not for the next 2 sessions. I look at the material we're gonna cover. It might come back to linear regression, nobody knows. But we talk about classification for almost 2 sessions, and then we'll talk about resampling, basically getting a better sense of, instead of working a lot on the modeling part of it, working more with the data and the way that we have to process and clean the data. And then we talk more about the model selection. We covered model selection slightly, not slightly, probably in depth about the linear regression ones, and we will cover it for classification ones and the other types of models we'll go through. So that's also a kind of a heads up for the next sessions, to keep you as excited as I expect you to be. So the whole class is not around linear regression. Have a question? Not really? All right. So that's the material that I wanted to cover on the second one. What I had to give you is basically finding the generating those plots. I'm hoping I find it somewhere in my codes. Probably none of these would be. Yeah, probably forgot about which part I was doing that. No, not really. That's a per capita one. Yeah, I probably forgot where to do that. Anyone can help? Or I can look at the course material actually. Yeah, the quadratic model, the plot. Already? So if I do, all right. So I just needed to plot the model basically. So if you plot the model, it would create all those. So it has the residuals, it has the coefficient, it has all the summary things that the textual one that we generated. So if you pass it to plot, it will automatically get it. So it will be the residual versus fitted for a model. You can see that again. For some of them, it assigns the ID, so it's easier for you to spot them across multiple plots. And then you hit enter again. It creates the QQ residuals. Those that fall apart, we have a really good model compared to the one that I had in my slides. You remember the ones that falling off of that line? We don't have much of it here. And then the scale location. Scale location had to have another one as well, and the Cook's distance. So Cook's distance for a so this is really good model because those are all like gathered in one place. The leverage one, the leverage plot. I think I can do it for another model to see if that one's good. They usually have confidence band. If the variables are far off from the Cook's distance, then we know those, not variables, data points. Then we know that we can clean those data points as well. So I can plot model interaction maybe to see how it goes. Unfortunately, all we have, so you see this one, these are the bands that I'm talking about. For the other one, we didn't have them. So we have these bands on the leverage plot. If the data points are far off from the Cook's distance, then we know that those are outliers. So these are different ways of knowing how our model is doing, what we need to do to improve the performance of it, either from data point of view or the model selection part of it. So these are two different angles that we can work with. Yeah, that's as much as I wanted to cover for this session. If there's any other, oh, and the other thing is that, yeah, that's about the items. Overall view of it, just to make sure I haven't missed any part we wanted to talk about. That's probably about it. The other thing is that for the homeworks, do you have any issues with needing R codes or any question about the part? So were you able to write the codes for homework and then getting the output as a PDF or HTML? Fine, without any issue, right? Though you might think that it didn't make sense, but you went through it successfully. Perfect. For the next homework, I will post it end of the day today or early tomorrow morning before I leave for work. So you'll have the solutions for this homework. You'll have the homeworks for the next week. I guess that's mainly it. If there's anything else you want to discuss, let me know.
Can you post next week's reading?
Next week's reading, I will post it tonight as soon as I get home as well. Sure. Makes sense. I want you to have them ahead of time. But the slides, as I mentioned, we don't have them until I make them. When I make them, I will post them. So hopefully soon. Sure. And I will put together the recording for today as well if you want to see it again, whatever. Should be able.
For the homework problems that we have to do, but by hand, like the two and one for this homework, I'll put that as an image, like write it by hand and put it as an image.
Sure. Yeah, that should be fine. Yeah, that should work well. Yeah. Oh, and one more thing for the office hours. So it's going to be between noon and 1 on Tuesdays. But would be great if you can send me an email. Let me know if you're going to attend it. Because otherwise I have to be around the whole hour. I don't know if anyone would show up or not. So that would help a lot. So if you know you're going to attend, let me know up to the point that it starts. So I try to make myself available through the hour. All right. Otherwise, I will stay around. Have any question, let me know until